prepare, explore, and cleaning data. If you ask a data scientist how much time they spend or where they spend most of their time, unfortunately, it's here. And it's not just like a little bit more. If you ask data scientists how much time they spend, 95% of the time that they're doing data science is here, unfortunately. It's the most boring part, right? But with R, you learn a lot, or if you become good at R, you get good at sort of doing this part, which is like sort of pushing the data around and cleaning it up and getting it sort of so that it works. Because if it's all messed up, you can't build a model with it. But actually 95% of what you need to do is here. The other stuff is the sophisticated part, but it doesn't take that much time. Okay? So and that's not a joke. I'm not like making it. It's not like I'm trying to BS you. It's at least in my experience, it's more than 95%. And then I just read online that everybody's the same. So it's the same. Okay. All right. So let's go on. Okay, working with R. R is case sensitive. What does that mean? What? Capital letters and small letters are different. Okay? An interpreted language. So in programming, there's two types of languages usually. We can divide. There are languages like C and basically languages like C, C++, and so on. And those are called compiled languages. And what that means is that you write the code, which is written in, like basically human language, not exactly human language, but it's written in some kind of language. You write the code, but the computer can't read that code. Computers don't read that code. You say like let x be equal to something like that. Computers don't read that. Okay? So what you do is you compile that. We say you compile it, which basically means you translate it into something that the computer can read, which is basically just a sequence of zeros and ones. So your whole program is converted into a sequence of zeros and ones. And then that gets in, when you download a program, that's what you're downloading, a sequence of zeros and ones. And then you install it, and then the computer runs it. Okay, and that's much faster. Once you've compiled it, the calculations will run much more quickly. So if you need to do a lot of calculations, and you have a compiled program, it's going to run much more quickly than if you're using R. Okay, so R is not as fast as compiled programs because R doesn't work like that. R is not a compiled program. It's not converted to a sequence of zeros and ones beforehand. Okay, so it doesn't run as quickly, but in some cases you can get it to run almost as quickly, or even sometimes more quickly, I've heard. So in R, you can enter commands one at a time at the command prompt. So you've been doing that, right? We've been entering our commands at the command prompt, right? Or we can actually run them run a set of commands from a file. So we can write a bunch of commands on a file. We can save that file, and then we can open it up with R, and it'll run a sequence of commands. So we'll learn how to do that. There are a wide variety of data types, including vectors, matrices, data frames, and lists. So anybody know what they mean by data types? Anybody done any other programming before? Anybody done any other programming? Well, in other programming languages, we talk about data types like integers, strings, real numbers. They're not usually called real numbers, they're usually called like doubles. But you can have things that are integers versus doubles versus strings versus true-false values. So why do we bother to make these distinctions? Why do we bother to make these distinctions? The reason is because if you define something to be a true-false value, that's called a Boolean value, then you only have to reserve a little bit of space for it in the memory of the computer, because it's only going to be true or false. Whereas if you define something to be a double, which is like a real number, then you need a lot of space to represent that number. And if it's text, it's even worse, because text can be really big. So it's really a question of sort of using the memory of the computer properly or efficiently. Okay, but languages do this. They separate things into these different data types. And in R, we don't exactly do that, but we have different kinds of data types. And one data type is a vector, and another is a matrix. Okay, now you had already experience with both of those, right? So the vector was this one here. What was the vector that we worked with today, either in your quiz or something I did? A vector just means when we said A is equal to C, 1, 2, 3. Right? Remember we just did that. When I type A next, what do I get? So you can try it right now. Just review that again. Do that assignment. It's called an assignment. When you assign something to a variable, it's called an assignment. So write that assignment, write that expression, and then type A at the bottom underneath it. And what do you get? You get 1, 2, 3, right? Okay, so 1, 2, 3 is a vector, just a list of numbers. Okay, like in math, we talk about a vector. It looks like this, right? I'm sure you've seen that, right? Vector. But we also identify this vector. Suppose this is A and this is 3. We identify it like this sometimes. A, 3. Okay? And if you had a 3-dimensional graph, you might have another dimension here. Right? 3 dimensions. Right? And then you might have a vector coming out like here, right? So it's going to have an x coordinate, it's going to have a y coordinate, so here it is out here. So it's going to have you go out a certain amount of the x, you go out a certain amount in this direction, and a certain amount up, right? And you get to the tip of the vector, right? So it has 3 coordinates, right? 3 coordinates, right? So it might be like 8, 3, 7, or something like that. Okay, so that's a vector also. So generally speaking, though, we work with, you can have as many elements in there as you want, so not just 3, you have 10. Okay, so a vector of length 10, okay, instead of a vector of length 3. Because we're not always talking about graphs, we're just talking about lists of numbers, but they still use the word vector. Okay? Okay. So let's see. Okay, what I'd like you to do for a few minutes is go back to chapter, if you haven't finished it yet, go back to chapter, what is it? You did 1 through 4. So you're supposed to finish up through 8 now. So I just ask you to work on that for a few minutes. I have to go outside. But go back to chapters 5 and 6 in the code school. So go back to code school. And try to work on chapters 5 and 6 right now. All right, so let's continue. So, okay, so anyway, we said about vectors, right? So this will give you a vector. 1, 2, 3. Okay? So that's one of the data types, so-called data types. And what's another one? Matrices. So you did some of that in code school, right? You created matrices. So that's another, what they call a data type. Okay? And there's some others. So we'll discuss each of these types in chapter 2. Most functionality is provided through built-in and user-created functions. So there's functions. Now, can anybody identify any functions that you've already seen? I didn't note them as functions, but I'm just asking if you might guess. Functions that you've already seen in code school? Sum. Sum is a function. Another one? Anybody else? Somebody give me another one? What? Help is a function, that's right. Anything else? Rep, R-E-P is a function, that's right. What else? Which one? Plot. Plot is a function, right? There was one on the quiz. Matrix is a function. There was another one on the quiz. Mean. Mean is a function. So what, how do we recognize that something is a function? Yeah, there were parentheses for all of those. Right? What? Plot, mean, sum. What else? Plot, mean, sum. Sum. Oh, sorry, I said that. Plot, mean, sum. What else? Matrix. What else? Which one? Square root. Did you have square root? Okay. Anyway, yeah, all of those. In fact, even this is a function. It's the combine function, or it's also called the concatenation function, combine function. Okay? Now, if you remember, by the way, when we talk about functions in high school, in mathematics, sometimes they'll describe a function like this. Anybody ever see this kind of description? Like, this is what they mean by a function in math. You never saw that? So, like, in math, we say, this is a function. Right? Same thing. It has the parentheses, right? So you put something in, the parentheses mean what? You put something in there, and then you get something out. Right? The same idea here. You know, when we do the mean, when we do the sum, when we do the anything. You put the parentheses are where you identify what you're putting in, and then you're going to hopefully get something out. Right? So like when we put in this, we get 1, 2, 3 out. If we set the mean of A, with this A already, if we already had this A, we'll get something out here, right? Well, we'll get a 2 out. Right? So we put something in, we get something out. That's the idea of a function. And that's what I learned when I was a kid. They said, you put something in, you do something, you compute the function, and then something comes out. Right? That's the idea of a function, right? So what goes in are usually called the arguments. I don't know why they're called arguments, but they're called the arguments. So, like if I say here, f of 6, right? The argument is 6. Okay, and then the output, or the y value, is 36, right? So the input is usually referred to as variously referred to as the argument or the input, whatever. Okay, a lot of different words they use, but it's what goes in. Okay, so so here they're saying most functionality is provided through built-in and user-created functions. Now, we haven't created our own functions, did we? No, we haven't learned how to do that yet. So, but we have used built-in functions. We used which ones? We used mean, we used sum, we used this combination function, right? We used a bunch of those are built in, right? We didn't have to write them ourselves. Okay? But a lot of times you want to be able to write your own function and then use it. You would write a function because you might want to use it repeatedly, many times. Okay, so most functionality is provided through built-in and user-created functions, and all data objects are kept in memory during an interactive session. So what that means is basically that all the stuff that is held, basically, it's just a weird distinction that maybe we don't need to think about too much, but basically it just means that it's being held in the memory. So that means you can't put too much stuff there, right? Because you have a limited memory, right? There's a difference between memory and hard drive, right? Hard drive is huge, right? Like maybe 1 terabyte. But memory is like, maybe, I think on these computers, memory could be as small as 2 gigabytes. Okay? So maybe you have a computer at home that has more than that. But anyway, they're just saying that everything that you're doing in R is going to be happening in the memory. So that makes it, important to be careful, right? Okay. Other functions are basic functions are available by default. Other functions are contained in packages that can be attached to a current session as needed. So these functions, we didn't have to do anything, we just use them. But there are many, many functions that are available, and if they were all immediately available, that means they'd all have to be loaded into memory. So we don't want to do that, right? So we break it down into steps. We say, okay, if you want to load a particular set of functions to do something, you can load them into memory, okay? Otherwise, they're not in memory because there'd be too much, right? There's probably tens of thousands of functions. So if you loaded them all into memory, you couldn't do anything, right? So they say, and all the other basic functions are available by default, so like the mean and the combine function and so on. Those are all, you don't have to do anything, you just use them. But other functions you have to do one step beforehand, bring them into the memory, and then use them. Okay? And the way that you do that is you use a command called library, and then you put in the name of the package that has all the functions that you want, or you can use the word require. There's some slight difference between using one of them versus using the other, and I forget exactly what it is, but you can use either one of them basically interchangeably. And they're going to be like packages of functions. And you say, oh, I want to do text mining. So there's a package called TM. So you just write this. And then you could use all the functions that were written in that text mining package. Okay? So, but that's the way R works. Okay? Statements consists of functions and assignments. R uses the symbol, this arrow, for assignments rather than the typical equal sign. For example, this. Okay, so we've been using this, but then I tried to use equal also, right? And actually you can use equal. I don't know. Our lovers. People who love R probably wouldn't appreciate that we use equal sign, but anyway. So this is something else. This will create a vector with 5 random numbers from a standard normal deviation. So let's try this. Try this one. Type this one into R, and then hit Enter, and then type X, and see what X looks like. So it's X. I'll use equals. Now, one good thing about RStudio is it tries to help you with this, right? So you don't remember the exact function name, but it gives you a suggestion, right? So the regular R interface doesn't do this. So that's another good thing about using RStudio. And then here, it also tries to help me. Look at that. It's also trying to help me. It says you put in N, then there are these other arguments that you can optionally specify, but we don't have to specify them. Anyway, we don't know what these mean, right? But these are other arguments that we can use, and here it's telling us that, right? We wouldn't sort of remember that, right? There's so many different functions, and unless you're using R like every day, you're going to forget so many different parts, right? So this is useful. Anyway, so we'll just put in the 5, and I'll hit Enter, and then hit X, and you get that. So let's examine this for a second. First of all, what data type might you think this is? Can you recognize that this is a vector? Okay, it's a vector. Here's the first element. Okay, here's the second element. Here's the third element, and so on. Okay, so it's a vector of 5 elements. And these numbers, I always think they're kind of silly, weird to do this way. But this 4 means that this is the 4th element. And this 1 means that this is the first element. So just a kind of helpful, like if you have a big list, that could be helpful. For example, if I did this, let me just do this. So what do you think I'm going to get now? I'm going to get 50 elements, so just watch. Now I hit X. Okay, so now what does this 10 mean? It means that this is the 10th element in the list. Okay, what does this 25 mean? It means this is so it's just kind of helpful, right? That's all that is. So can you recognize, first of all, that this is a list of numbers? Okay, so it's a vector, right? This is a vector. Okay? And what would you say about these numbers? Anything? Any observations about these? None of them seem to be that big, right? And they do seem to span positive and negatives, right? There are some positives and some negative numbers there. Okay? So how about if I took the mean? So you can write the same thing here. You can do this, right? You can do 50, or you could even do 500. So what does the 50 tell me, by the way? It's the number of numbers I'm going to generate, right? So before you did 5, you generated 5 numbers, right? Yes? Oh, yeah, I'll get to that in a second, yeah. Good question. So, yeah, he observed, although I'm not sure how you observed it, except you looked at the other person, right? But he observed that you don't get the same, he and his person next to him are not getting the same results. So that's true. It's true. So that's interesting, right? Anyway, did everyone try it with, say, 50? Okay, now suppose you wanted to know the mean of this list of numbers. How could you do that? So you could type in mean, open bracket, right? And then what? I called it x, so I could do x. Okay, so what do I get? Negative 0.02, right? So everybody probably gets something different because your numbers are different, right? I don't think anybody gets exactly this number, right? Okay. But I can guess that everybody gets something very close to 0. Mine is close to 0, and I can guess that everybody else's is close to 0. By the way, you can also do this. Can you see what I'm doing? Do you see what I did? Putting x in there, you can put one function inside another. Does everyone see what I did here? I put r norm inside of the mean. Instead of doing mean x, you can do mean of r norm 50, right? You can do that in R, and that's a very typical thing to do. Okay? But anyway, we'll get something similar. Not exactly the same, of course. Okay? So what is this R norm? I mean, this is not something I wanted to talk about, but this is taking, R stands for random selection from the so-called normal distribution. So what's the normal distribution? It means that we're choosing numbers at random from a curve that looks like this. So this is 0, 1, 2, -1, -2. And what this curve, what I mean by this curve is it higher at 0 or is it higher at 2? It's higher at 0, right? The curve is higher at 0, right? So it means that we have a greater probability, the height is dictating the probability of getting such a number. So we have a greater probability of getting a number around 0 than we do of getting a number way out here when we use this function. Okay? Understand? So if you look at it, do we have more numbers that are close to 0 or more numbers that are close to 2? So you don't see almost any number that is close to 2, right? But you see lots of numbers that are close to 0, right? Because the way it's selecting numbers is based on this curve. This is a probability curve, and it's saying, if, only select numbers out here just a few percent of the time, but select numbers out here a lot. Okay? So that's another function, obviously. Right? What was the input for this function? What was the input in this example? In this last type, what I typed last. What was the input? Not that one. Yeah, the input into here. 50, right? So I put in 50, and then it gave me what? A list of 50 numbers, right? Most of them are close to 0. They can be positive or negative, and it's possible to get something as big as 2, but I don't see very many cases of that. Here's a 1.7, right? It's very unlikely that we'll get something as big as 2, and even more unlikely that we'll get something as big as 3, and so on, right? Okay, so that's why everybody got different numbers, because it's randomly selected, but the average for everybody was close to the same thing, right? Because it's generally going to be close to 0. Okay, so, all right. So you have some homework. So your homework will include now finishing Code School and read through this and try out some of this stuff, but we'll come back and review this or do it again together, this PowerPoint. And that's all I think I said. Did I mention any other homework? No. But I will ask you also to send your photo to me by email, but I'll do that later. Okay? And this video that I was just recording here, so I'll post this on YouTube in case you want to go back and check it. Okay? And anybody who got less than 70%, less than 70%, please come up and see me up here on our quiz. Anybody who got less than 70%.